Okay, hey there everyone. Last night's homework was all the questions that we did on that meteorology packet. So I'm going to pick up on the questions that we didn't do and then finish this lab, and that's basically what we're going to do today. So what's the general appearance of isotherms on this map? So this is the first map that we looked at. We take a look at the iso lines going across the map, okay? And they don't cross because they're iso lines, okay? And they also increase in value. So, what is the general appearance of isotherms on this map? They, lines run parallel. Lines run parallel. And increase in value, north to south. Okay. Number 7. How would the temperature change if we went from Bismarck to Denver? So Bismarck is about 30 degrees. Denver is about 51. So if I'm going from Denver to Bismarck, again 51 to 30, it's going to decrease in, which corresponds to what we just wrote there, because it increases north to south. Denver's south of Bismarck, so value's got to go down. Okay. Where or how would the temperature change if you were to drive from Cincinnati to Chicago? Cincinnati sits at about 60 degrees. Chicago sits at about 40 on the map. So you can answer that one for your house. I'm not filling that one in. How do the isotherms on this map support the relationship between the angle of insolation and latitude? Okay, angle of insolation and latitude. As the angle decreases, angle of what? Angle of the sun's light decreases. What happens to the temperature? Okay? Temp decreases. This comes right from our lab that we did about 3 weeks ago on angle of insulation, where we had the wooden blocks and the heat lamps. So, as the angle decreases, the temp decreases. And the angle itself decreases as latitude increases. Okay, identify 2 cities where the temperature gradient is the greatest. Where would the temperature gradient be the greatest? So if we take a look at the temperature gradient, we want to have a lot of lines packed in together. So what I'm going to do is I'm going to do one of them for you, and another one you have to come up with yourself. So you need, and it should be 2 pairs of cities. First pair I'm going to give you as a good example of a pair of cities would be Seattle and Calgary. Why Seattle and Calgary? Because we have 3 lines in between those 2 cities, and they're pretty close together. So you should find a place on the east coast of the United States where you have 2 lines pinched together between 2 cities, and it's pretty tight, okay? That's your other answer that you're doing independently, okay? So, these 2, extra credit. Okay, if you want to do them, the scale's on the map, okay? And you can measure between the cities. In order to do gradient, it's high minus low divided by the distance. Entirely up to you. Okay, for the conclusion is basically number 6. You have to rewrite it in a conclusion form and use complete sentences. But basically, number 6, which is right there. Because if you look at the purpose, it's basically question number 6. Okay? So, then, continuing, let's go on to wind. So, you had to do 1 through 3 and 6 and 7. So that means we have to do 4 and 5. You should actually be able to do 4 and 5 by yourself because of what we have in our notes, but I'm still going to give it to you. So, describe the general surface wind patterns around the low pressure center. So, low pressure, counterclockwise, and inward towards the center of the lobe. Okay, describe the general surface wind patterns around the high pressure. Well, low pressure is counterclockwise inwards. You should be able to do number 5 because it might be the opposite. Not sure, but possibly. Okay, so we now need to take a look at number 8. Between what two pairs of cities does the wind shift the most? So we want a big shifted wind. Okay, where our arrows change direction. Okay, I'm going to start up, and this one would be those big giant arrows. One of them, there's a big left-hand turn arrow on the page, one of those larger ones that you drew. I'm going to do one that's not so obvious, but it's pretty big change. And that would be Cincinnati. I just misspelled Cincinnati. I'm not worried about it. And the city of Chicago. Okay, those two cities, you have Chicago out of the northwest and Cincinnati out of the southwest. Big difference in wind direction. You should be able to find another pair of cities that has a huge change in wind direction. Again, pretty close to each other and big change in wind direction. Okay, so the conclusion. This one is to describe the wind pressure, the surface winds around high and low pressure. So, for this one, it's questions 4 and 5 that you're rewriting. Four and 5 together, describing high and low pressure. Pretty simple. You should be able to get that. And if you don't have any, if you do have significant issues on any of these conclusion questions, it's okay. I'll go over them tomorrow. Okay, or we might be watching another one of these because the weather looks pretty similar to what you get today tomorrow. So 1 through 3 and number 9. So that means we have to do number 4. Number 4 is a really important one, okay? And I'm glad you're watching this video. Maybe you're going to even re-watch it before the test next week because this one's really important. Step by step, how do clouds form over low pressure? First thing, air rises. Okay? 2, the air expands. Why does it expand? Because there's less pressure up there, so the air can expand. When it expands, the air cools. So, air rises, air expands, gets cool because there's an expansion. Less molecules means it's going to be cooler. Okay? 4, after the air expands, the air reaches the dew point. And last but not least, 5, water vapor condenses. Step-by-step process. The problem is kids want to add a step in before that and say, ooh, but Mr. Perry, the water vapor has to evaporate to get into the air so then it can rise and yada, yada, yada. But the last step of the process is condensation. So if you were to say evaporation at the beginning of the process, you've just gone too far because they're opposites. And if you write down evaporation on a question that's like this on the exam, I gotta mark it wrong. Evaporation and condensation are opposite processes. So when we write how clouds form, it's air. The water vapor is already in the air. Don't put it there. You don't need to put it there. It's there. It's by itself. So air rises, air expands, air cools, air reaches the dew point, and the water vapor condenses. That's a lot, but it should be something that you can handle. Okay, number 5. Compared to areas of low pressure, how do areas of high pressure have fewer clouds? Or why do areas of high pressure have fewer clouds? Because the first step in getting clouds to form is air rising. If the air is not rising, you have no clouds. Okay, so if you don't have any, well, duh, it already stopped the process. Okay, so why do areas of high pressure have fewer clouds? Air isn't rising. No clouds. The air's not rising, there won't be any clouds. High pressure, air is sinking. Okay, if you were to drive from Hatteras to Buffalo, describe the weather you would drive through between the two cities. So Hatteras, 68, it's warm. Warm. and cloudy. Drive through rain. Where's the rain come from, Mr. Perry? Because you're crossing the warm front from south to north. Buffalo, cool and cloudy. If you were to fly from Salt Lake City to New York, describe what you'd see. Clear skies over most of the United States until the rest for the first half of the trip, and the second half of the trip you're flying over clouds, and when you land in New York City it's raining. Mr. Perry, how'd you do that? It's pretty simple. Okay? Look at the weather map. All of the moisture is in the eastern half of the United States. So that's why I can say the first half of the plane trip it's going to be clear, the second half it's going to be cloudy, and you're going to have rain when you land in New York because New York is rainy on the map. Okay. Estimate what two cities will be receiving rain soon. Okay, remember our weather systems move from west to east. Almost always. The weather that we're getting today is not. It's actually called a nor'easter, so it's moving backwards. But we're going to leave that one off the table. We're not worried about that one. We're worried about this system in our map. Okay, so we had our big giant swath of moisture here. Okay, and the low's at the center of it. So this whole thing is moving to the west, or moving to the east, going west to east, and it's rotating counterclockwise. So, as I move and pivot, this is going to begin to hit cities like Chattanooga, Atlanta, Buffalo, and Boston. How did I do that, Mr. Perry? Because this whole thing is moving from west to east and rotating. So this section and this section are going like this. Okay? It's moving, but also turning and pivoting. So that's why Buffalo and Boston are going to get the rain. Okay? So, with that being said, you have your cities now. You can finish that up. And then it says, okay, you did number 9 hopefully for homework. So let's see, what city's dew point was closest to the temperature? This is a really good one. This is one that you got to know. Okay, relative humidity, if you look on the relative humidity chart, if you haven't noticed, when it's 100%, the temperature and the dew point are together. They're always locked together. The one that has mist floating in the sky would be Chicago because it's foggy. And typically if you look for where the temperature and the dew point are the same, it would be Chicago. So, or I should say it would be the areas with fog. Conclusion. The purpose was to describe where the rain falls with relation to the air masses. So we're going to scroll back up here. So we had our MT here and our CP here. The rain's not falling at the MT, it's not falling at the CP, it's falling in between them, okay? Because it's stuck in between. It's where the two air masses are battling it out, okay? And where the air masses are battling out, that's where the rain occurs. So, conclusion. Rain / storms occur in between air masses. Okay? Okay, we're going to skip right to the chase because I want to make this shorter. Okay, so I gave you for pressure 1 through 6. I'm giving you some more just to make sure that you should have done these for your answers, but I'm going to let you check your answers, okay? Okay, between what two pairs of cities the pressure gradient the greatest? It's where the lines are packed in the closest. So between Atlanta and Jacksonville would be a good answer. Between Boise and Salt Lake. There's others, so if you did something different, it's okay. Identify the cities with the 2 greatest wind speeds. This is one that you have to know. Have to know. How do I know where the greatest wind speed is? It's where the isobars are closest together. It's not where it's high, it's not where it's low, it's in between when they're packed up or bunched up together. Okay? So, if I look at Atlanta and Jacksonville, that's where there's wind. If I look at between Boise and Salt Lake, that's where there's wind. If I look between Chicago and Minneapolis, that's where there's wind. Okay? So those are all good examples of where there's wind, and you have to understand that. And if I'm like Mr. Perry just gave us all the answers, okay? We're doing a second version of this lab tomorrow, okay? Or we'll be doing it again through YouTube video because I won't see you tomorrow because it'll probably be more snow and after-school activities will be canceled again. But regardless, what you see is what you get. Questions, comments, concerns? Well, if you do have questions, make a note and please ask me the next time we see each other, okay? So, last but not least, we have to do the synoptic weather map. Don't say. So let's talk about the synoptic weather map. The synoptic weather map, you actually have all the data to do at home. Okay, there's only one more piece that we're going to throw up there. Okay, so here's the synoptic weather map. Synoptic weather map. We're going to bring over the information. First thing is, purpose of the synoptic weather map is to determine the pressure of which brings inclement weather. Inclement is a bigger word. Inclement means stormy weather. Okay? Weather that brings action, excitement, or moisture from the sky. Okay? Determine which way all pressure systems move. Another one. So there's two purposes to this lab. So the first thing we're going to do in the direction is bring over our pressures. Okay? These are our isobars that you already drew. They're already on your pressure map. You've already drawn. So you're going to bring that information over. Okay? Second, shorten the video, you have to bring over the precipitation from the precipitation map. So you're bringing this over. Notice where the L is. It's at the bend in the precipitation. There's a reason for that. There's a purpose for that. Because that's where the fronts are meeting. Okay? Fronts are where the air is battling out. We just said it, in between the two air masses. So we have a front going this way and a front going that way. So our first front, if we take a look at the temperature map, we can see the isotherms dip way low and curve up towards Cincinnati here. I mentioned that yesterday in class, that there's something going on here. Well, the something going on is a cold front. Cold front is symbolized by triangles. They always point down or some tangential direction to down, okay? Because cold icicles always hang down, okay? So, go in that direction, okay? Why is it going this direction? Because the arrows or the triangles indicate the direction that it's moving, okay? Counterclockwise, okay? So, counterclockwise, moving this way. So the cold temperature drop is going to happen in Chattanooga. It's going to happen in New Orleans very soon, if it hasn't already. Okay, that type of motion, there you go. Okay, then we get to our warm front. Warm front's right here, okay? Notice where the cold front happens right in the middle of the rain. But the warm front actually happens behind the rain. The rain is up here, the warm front is here. Why does it happen? Remember, as we drew our diagrams, the air moving over the cold air mass, the warm air, already wants to rise, so it's having a hard time pushing it out of the way. So the front actually is behind the rain. The rain happens in front of the front, okay? And it's over a much wider area. Notice that this is a fatter area than this one. Not much. It should be exaggerated a little more. But this is areas of much wider swath of moisture than this stripe right here, okay? So, you've gotten that down, okay? And that's pretty much what needs to be done to the synoptic weather map, okay? So, let's finish this up really quick, and then you guys can be done watching a YouTube video today. And that is, we're taking a look at the synoptic questions. I didn't have you do any of them. You should be able to do 1 and 2. So that means that we will do a few of the remainders on 3 and 4. Okay? So, synoptic weather map. Here we go. So, we have our synoptic weather map. You need to do 1 and 2. Pretty straightforward. You should be able to do that. Some of the ones we're going to do right now. Okay. Generally, what direction is the entire low pressure system moving? Okay. Excluding today's weather system because it's a nor'easter. All weather systems in our neck of the woods, being the continental United States, move from west to east. They move from west to east. So, west to east. High pressure systems follow the same direction. West to east. Okay, no trick question there. Okay, in general, describe the weather occurring near a warm front. This is right out of your notes. Notes 8 on fronts. Copy it down, learn it, love it, let it be one. Okay? Is it cloudy? Is it light rain? I'm going to tell you it's going to be cloudy. You just got to tell me whether it's light rain or heavy rain. Okay, in general, what's occurring near a cold front? cloudy, light or heavy rain. You got to tell me that, plus the temperature change. What happens with regards to a warm front, hint, and cold front, hint. Okay, so where do the fronts form in relation to the two air masses? Geez, I think I repeated this like, I don't know, 5 minutes ago. In between them. Okay, what are the differences between CP and MT air masses? CP and MT air masses. We know this. You talked about, or we did this in notes on Monday, okay? What's the characteristics? The characteristics are continental polar, cold and dry, and maritime and tropical, or moist and tropical, okay? Warm and wet. So what are the differences? Temperature and something else. Okay, so you have to figure out, give me that something else, okay? High-speed winds near the ground, changes in air pressure. Identify a region where there are wind speeds are the greatest. Again, just talked about this, okay? There's a couple areas. In fact, you identified them on your winds map. Go back to the winds questions and read your answers, okay? Or the pressure one or the other. Identify two cities which are recording the highest wind speeds. Again, basically it's the same question done over again. Conclusion, you have to tell me what weather system brings inclement weather. Look at the map, look for the clouds, tell me that. And then you have to tell me how each of them are moving. Okay? So it's a combination of either 1 or 2 and 3, 4. Okay? 1/2 and 3, 4. Okay, packet is done. You're golden. Okay, I'm hoping to have this uploaded in a very short period of time, and I miss seeing you guys today. Bye.